Hi friends, good morning to everyone. Welcome to my channel, Belagali's class. Belagali's class. My friends, we have started with applications of trigonometry, that too heights and distances of various objects. Okay. My friends, already we know what I mean by angle of elevation and angle of depression. If the object is above the horizontal level, then the angle formed is known as angle formed by what? A line of sight with horizontal is known as angle of elevation. If the object lies below the horizontal, then angle made by the line of sight with horizontal, that angle is called as angle of depression. We know them, and we have started doing the examples based on angle of elevation and angle of depressions. Now we have done fairly some examples, selecting some examples from the exercise 12.1. Exercise 12.1. Now this is example number 9, what you are seeing on the board. What it says, my friends, example number 9. The angle of elevation of top of a building, the friend is top of the building, from the foot of the tower is 30 degrees, and the angle of elevation of the top of the tower from the building is 60 degrees. From the building is 60 degrees, means foot of the building. Here you have to just see, it is also foot of the building. Foot of the building is 60 degrees from the foot of the building. Is 60 degrees. If the tower is 50 meter high, then find the height of the building. My friends, this is building. This side is building. This side is, it is a tower. It is a tower. My friends, let A be equal to H be the height of the building, and CD equal to 50 meter, it is given C. If the tower is of 50 meter high, the height of the tower is 50 meter, then you want to find the height of this building. Now what are the givens? When the observer is at the point A, and there are two observing points. One is here, observing point is D. What is this D? Foot of the tower. From the foot of the tower, if you look at the top of the building, foot of the tower to top of the building, the angle of elevation is 30 degrees. Fine. This is the horizontal. BD is the horizontal, then it is above. Both the objects are above the horizontal, means angle of elevations. Yes. From the foot of the tower, if you see the top of the building, the angle formed is 30 degrees. Similarly, from the bottom or the foot of the building, if you look at top of the tower, the angle formed is 60 degrees. Both are angle of elevations. Therefore, given angle ADB, this is what? From the top of building to bottom or foot of the perpendicular, angle formed is 30 degrees. What is next? Angle CBD. What is C? Top of the tower. What is B? Foot of the perpendicular, formed is 60 degrees. 60 degrees. Yes, once again what? My friends, small triangle tan 30, big triangle tan 60. What is this? From the triangle ABD, tan 30 is opposite side, AB upon adjacent side, AB upon B. What is tan 30? 1 by root 3. AB, we have taken it as h. BD, you write it as it is. Then you solve for BD. Take 1 into BD, h into root 3. You name this as 1. Then similarly from the triangle BCD, this bigger triangle, BCD, tan 60. Opposite side is CD upon adjacent side is BD. This BD is common for both the triangles. Adjacent side BD is common for this small triangle as well as this big triangle. Therefore, what is tan 60? Opposite. CD upon BD. Now, what is the value of tan 60? Root 3. What is the value of CD? 50 upon BD. Therefore, solving for BD, BD equal to 50 upon root 3. Name this as 2, name this as 1. It is also BD, it is also BD, equating from 1 and 2 for BD. Therefore, I have written in a simple way, from 1 and 2, both the values are equal to BD. So, you can equate them. So, root 3 into h in 1 equal to 50 upon root 3. Root 3 into root 3 is what? 3h. Root 3 into root 3 is 3h equal to 50. So, the value of h is 50 upon 3. Divide 50 by 3. 1. 20 means 18, 16. 20 means 6, 6. Therefore, what is this h, my friend? This h is nothing but height of the building. Height of the building is 16.66 meters. 16.66 meters. That will be height of the, my friend, building. Yes, copy it. 1 minute time, my friends. 1 minute. Yes. Friend, the next example is example number 10. Example number 10. Yes. Example number 10. Two poles of equal heights. Example number 10. Example number 10. Two poles. Poles of equal heights. Equal heights are standing opposite to each other. Opposite to each other. Each other on either side of the road. Either side of the road. Road which is 80 meter wide. That road is 80 meter wide. From a point between them. Point is between the two poles, between them on the road. The angles of elevation, the angles elevation to the top, of the poles are 60 and 30 degrees. 60 and 30 degrees respectively. Find the height of the poles. First question. Heights of the poles. This is first question, and their distances from the point, or the distances of the point, from the poles. Find their distances. And the distance of the point, and the distance of the point, from the poles. This is the question. Read, my friends, carefully. There are two poles first represented. This is the ground. These are the two poles, my friends, of equal heights. Height of the poles are equal. This is one pole with equal pole height. This is second pole. Then the point is settled here. Say they are P1, P2 are the poles. P1, P2 are the poles. The point is settled here. This is the point. Then the friend is observing. This is your observing point. Angle of elevations, the top of this pole, P1. This is 60 degrees. Then second is here, my friend. Second is here. This is 30 degrees. This is 30 degrees. This is 30 degrees. 30 degrees. Say, now this is first pole AB. And this is a second pole CD of equal height. In both cases, the height is same. These are the angles given. And one more thing is given. The road is 80 meter wide. This is 80 meter wide. Now, if you take this equal to x, this is the observing point. If this is x, then what is this, my friend? 80 minus x. This is 80 minus x. Total road is 80 meter from here to here. 80 meter from here to here. This is the cinema. I have to write. Let AB equal to CD. H, given poles are given poles. O is the observing point. O is the observing point on the road. On the road, given angle of elevations. First is this, my friends. 30 and 60 and 30. First is this. First is what? Angle COD. COD is 60 degrees. And angle AOB is 30 degrees. 30 degrees. Then again, one by one you have to take. One by one you have to take. First triangle. Before that, one more is there. That is about the X. Above the X. Another is what? This BD. 18 meter given. Road, wide road, 80 meter wide. 80 meter BD. Let OD equal to X. Then my friend, OB equal to, it is 80 minus X. 80 minus X. One by one. First triangle. From triangle, see my friend, from triangle OCD, tan 60, OCD, tan 60 equal to, tan 60. Tan 60 is CD, opposite side. OD is adjacent side. This is CD upon OD. Tan 60 is root 3. CD we have taken H. CD we have taken H. And what is OD is taken as X. This is X. From this, what is the value of H? H equal to root 3 into X. This is, name this as 1. This is 1. Similarly, from other triangle, what is other triangle? Triangle AOB. From triangle AOB, second triangle. AOB. We have tan 30 in this case. Pi angle in the triangle is 30 degrees. Tan 30. Opposite side is AB upon adjacent side is OB. Opposite AB upon OB. AB upon OB. Tan 30 is 1 by root 3. AB is H. 80 minus X. Solve for H. Therefore, H equal to, this is simplifying 80 minus X upon root 3. My friends, how to simplify it? Name this as 2. See, bring here 80 minus X, down comes to the numerator upon root 3 equal to H. Now, from 1 H is this, from 2 H is this. From 1 and 2 equating for H we get. From 1 and 2 equating for H. 1 and 2. Equating for h, we get here in 1, what is this? It is root 3 into x equal to, this is 80 minus x upon root 3. Root 3 into root 3 is 3x, is 80 minus x. Bring this side. 3x plus x is 4x. 3x plus x is 4x. 80. So 4x equal to 80. 4x equal to 80 gives the value of x is 20. This is first, my friend. X is 20. This is x. X is 20. Then this is OD. OD is x. Therefore, OD is x, which is 20 meter. Next, OB. It is 80 minus x, which is 80 minus 20. This is 60 meters. 60 meters. Now, see, the distances of the poles from the observing point. One is 20, another is 60 meters. Then you wanted the value of h, height of the pole. And from 1, h equal to, it is root 3 into x, which is h equal to, root 3 is 1.73 into x is 20. If you simplify this, you will get it this equal to 34.6. If you simplify it, 17 into 2 is what? 34. What is it? 34.6. Therefore, height of the poles, or for each pole is 34.6 meter, and required distances of poles from O, observing point, are first is 20, next is 20 meter and 60 meters respectively. 20 and 60 meters respectively. This is 20, this is 60. This is 60. Yes, my friends, go through the example. If you want, I will explain once again. Yes, my friends, there are two poles of equal heights. We have taken each height of each pole is h. First, second pole. This is the observing point in between, such that angle of elevations to the top of the poles from this point are they are 60 and 30 respectively. They are 60 and 30 respectively. 60 and 30 respectively. This angle of elevations. 60 and 30. Yes. Then the wide of the road, that width of the road is given, which is 80 meters. Width of the road is 80 meters. 80 meters. Then you want to find first height of the poles, then the distances of these two poles from the observing point, OD and OX. Let equal to h are given poles. O is the observing point, and these are what? Angle of elevations. BD is given. From the first triangle COD tan 60, CD upon OD, CD upon OD, H upon OD is X. Therefore, the value of H is root 3 into X. Everything I've written neatly. From the second triangle, this is AOB, this tan 30, opposite upon adjacent side. It is H upon 80 minus X. Solve for H. H is 80 minus X upon root 3. 1 and 2. From 1 and 2, solving for what H or equating for H, you get RHS of 1 should be equal to RHS of 2, 5. Both LHS are equal to H. This equal to this. Root 3 into root 3. Root 3 into root 3 is 3. 3 into X equal to 80 minus X. 3x plus X is 4x equal to 80x is 20. What is that X? X is OD, my friend. X is OD. This is the distance of the pole from observing point. Then what about the second pole, OB, 80 minus X, 80 minus 20, 60. Then from 1, what is the H? Root 3 into 20. What is root 3? 1.73 into 20. If you simplify this, you get what? 34.6. H means height of the pole. Height of each pole. Height of each pole is what? 34.6 meters. And required distances of poles from the observing point are, this side is 20, that side is 60. This is the example. My friends, it is also one good example. Next example I have selected is example number 8. Example number 8. Yes, friends, this is example number 8. Yes, this is example number 8 of exercise 12.1. Yes, a statue 1.6 meter high, tall, you can say, meter tall, stands on the top of pedestal This is statue. This is its height, pedestal. From a point on the ground. The point is on the ground. the angle of elevation of the top of the statue is 60 degrees, is 60, and from the same point the angle of elevation of the top of the pedestal is 45 degrees. Find the height of the pedestal. Find the height of the pedestal. This is the question. Text. On the ground. This is the ground. On the ground. Statue stands on the pedestal. Yes, first you have to draw the pedestal. Yes, this is the pedestal. On this, there is a statue. There is a statue. This is pedestal. Statue. Let my friend AB be the pedestal. AB be the pedestal and BC be the statue. The height of the statue is 1.6 meter. 1.6 meter. Then there is an observing point on the ground. This is the observing point on the ground. Once the friend looks at the top of the statue, the angle created is 60. This is 60 degrees. Then, top of the pedestal, the angle created is 45 degrees. The angle formed is 45 degrees. Then you want to find what is the height of the pedestal. We have taken this as h. Height of the pedestal. Yes, write the things, man. Let AB equal to h be the pedestal. And BC is 1.6 meter. Be the statue. Then directly write Angle of elevations given. Angle of elevations are first angle COA is 60 degrees. Angle COA, angle BOA is 45 degrees. 45 degrees. Is correct? Yes, my friends. One time you take tan 60, another time you take what? Tan 45. Tan 45. Yes, right there. Yes, right. For tan 45, you have to take the triangle AOB from triangle AOB first. Triangle AOB. Tan 45 you have to take. Tan 45. This is, my friend, small triangle. Tan 45. What is opposite side? AB upon OA. AB upon OA. This is AB upon OA. Tan 45 is 1 equal to, what is AB? AB, we have taken it as H. H upon OA. Therefore, from this you get, my friends, OA is also H. OA is H. Second, from another triangle, this is what? AOB. What is another triangle? AOC next. From triangle AOC. From triangle AOC. AOC, you have to take tan 60. This is 60 degrees. This is 60 degrees, tan 60. Tan 60, again opposite side, AC. Upon adjacent side is OA. OA. What is tan 60? Root 3. What is AC, my friend? AC is AB plus BC. AC is AB plus BC upon OA. Put the values. What is AB? AB is H. What is BC? 1.6. This is H plus 1.6 upon OA is also H. This is from 1, my friends. From 1 is H. This side is root 3. So bring this side. It is root 3 into H equal to H plus 1.6. Bring H this side. So this is root 3 into H. Minus H is 1.6. Yes, H is common. It is root 3 minus 1 equal to 1.6. This is H into L. What is this? 1.73 minus 1 equal to 1.6. Hope understood. Always the value of root 3 is what? Root 3 is 1.73. 1.73. So this is H into 0.73 equal to 1.6. This is h into what is 0.73. 73 upon 100 equal to 1.6 means 6 upon 10. My friend, this cancel. Therefore, h equal to 16 into 10 upon 73. This h equal to 16 into 73 upon 10 becomes 10 upon 73, which is 160 upon 73 equal to, this is 2.5. 73 into 2 is 146. 146. You are left with, if you simplify this, this is 2.18. Therefore, what is h, my friend? That h is nothing but height of the pedestal. Height of the pedestal. Therefore, height of the pedestal equal to, it is 2.18 meters, my friend. 2.18 meters. This is another good example, my friends. Another good example. If you want, I will explain once again. Copy it. I will explain once again. Yes, friends. Yes, friends. A statue 1.6 meter tall stands on the top of a pedestal. This is, my friends, pedestal. Where is your statue? On the top of the pedestal. Its height, tall, is 1.6 meters. From the point on the ground, this is the ground. It is a point on the ground. The angle of elevation of the top of the statue is 60 degrees. Same time, same point. Top of the pedestal, angle of elevation is 45 degrees. Find the height of the pedestal. Let, my friend, AB equal to h be the height of the pedestal. BC equal to 1.6 be the height of the statue. These are angle of elevations. One is 60, another is 45 degrees. Then first you take tan 60 or tan 45. From that, which triangle? From the triangle OAB or AOB, tan 45 is opposite is h upon OA. Tan 45 is 1. Then OA, the value of OA is h. Next, another triangle. From the triangle AOC, tan 60 opposite AC upon OA. What is AC? It is AB plus BC. What is AB? H. What is BC? 1.6 upon OA. OA is also what? From 1 it is H. Because from 1. Because from 1 H. Simplify. Root 3 into H equal to H plus 1.6. Bring this side. Root 3 into H minus H. H is common. Root 3 minus 1 equal to 1.6. We know the value of root 3 is 1.73 minus 1. You are left with 0.73 equal to 1.6. Convert in terms of fraction. That 0 is cancelled from both sides. H equal to RHS 16 into 73 upon 10. Taking this side is 10 upon 73. 16 into 10 is 160 upon 73. If you divide, you get 2.18. Therefore, H is nothing but height of the pedestal. So the height of the pedestal is 2.18 meters. 18 meters. Then I do one more, the last example. Yes, my friends. Last example. This is example number 5. This is, next is example number 5. Example number 5. Example number 5. A kite is flying. A kite is flying at a height at a height of 60 meters above the ground. Above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string, inclination of the string with the ground is 60 degrees. Find the length of the string. Find the length of the string, assuming there is no slack. Assuming there is no slack in the string. No slack in the string. Yes, my friend. A kite is flying at a height of 60 meters. Height is 60 meters. Kite. Above the ground. The string attached to the kite is temporarily tied to a point on the ground. on the ground. The inclination of the string which the ground is 60 degrees. Is 60 degrees. Find the length of the string. Find the length of the string. Assuming there is no slack in the string. No slack in the string. Yes, my friends, this is the ground. This is the ground. This is the ground. Yes, and this is the point on the ground. Point on the ground. This is the kite from here, my friends. The kite is here. This is the kite. The point is there, it is right here. Then this is at a distance 60 meters from the ground. This is 60 meters from the ground. This height of the kite. The angle of elevation is given as 60 degrees. Then you want to find this length of the string, my friends. Length of the string. Take. This is AB. AB, where A is the top and B is the bottom of that height. Yes. My friend, given AB equal to 60 meters and angle AOB is 60 degrees. It is quite simple. Directly, if you take tan 60, you get the answer. Directly, if you take what? Tan 60. Tan 60. Yes, friends. From the triangle AOB, tan 60. Tan 60 is opposite side is AB. No tan 65. We do not know OB. We do not know OB. But we wanted what? We wanted OA. What is OA? It is length of the string. Length of the string. Assuming there is no slack. We wanted this length. Instead of tan, you have to take what? Sine in this case. Opposite side upon hypotenuse. Instead of tan, you have to take sine. Sine 60. Sine 60. Opposite side AB. AB upon hypotenuse is OA. Sine 60 is 3 by 2. AB is 60 upon OA. Therefore, what is OA, my friend? OA is 60 into 2 by root 3. 60 into 2 by root 3, which is, tell my friend, this is 120. This is 120 upon root 3. Can be written as 120 upon root 3 into root 3 upon root 3, which is 120 into root 3, denominator is 3, root 3 into 3, cancellation. This is 40 equal to 40 into root 3, which is 40 into What is the value of root 3? 1.73. If you simplify this, you get it as 69.2. 69.2. Therefore, my friend, length of the string, length of the string equal to, this is 69.2 meters. It is a good question, simple example. Sometimes they may give this example because the students will confuse here in the statement itself. But it is a quite simple example. Simple. Yes, copy it, my friends. Last, I will explain this once again. See, friend. A kite is flying here. A kite is flying at a height of 60 meters from the ground or above the ground. The string is attached to the kite temporarily, tied to a point on the ground. This is tied to a point on the ground. The inclination of the string with the ground. The inclination of the string with the ground is 60 degrees. The inclination of the string with the ground is 60 degrees. Find the length of the string. This is now OA. Find the length of the string, assuming that there is no slack in between. Yes. Given AB equal to 60. Angle of elevation 60 degrees. Directly, you can't take tan in this case. We wanted the value of OA. For that, instead of tan, we have to take sine 60. Opposite upon hypotenuse. 60 upon OA. What is sine 60? Root 3 by 2. 60 upon OA. OA equal to 60, taking this side 2 by root 3. 120 upon root 3. Multiply and divide. 120 into root 3 upon root 3 into root 3 is 3. Cancellation. 40 into root 3. Substituting value of what? Root 3. Simplifying, you get it as what? 69.2 meters. That is length of the string, my friends. Length of the string. Yes. These are some 4-5 examples that I have selected. In one more video, I do few more examples, and the 3-4 examples from this heights and distances, my friends, that I do in the next video, next class. Till then, my friends, bye, goodbye, namaste, namaskara, my friends, namaste. Good day, very good.